Okay, so I'm going to look at how to create a particular a particular cost structure. Okay, so assignment is to create. Let's sharing this document here. To create a spreadsheet showing returns to specialization in production. And what we're going to do after that is show what we call diminishing returns to a fixed factor. And we're assuming that all the costs of productions are covered in some way except labor. So we're looking at labor as our input. And this is not too far-fetched, seeing that some nonprofits have somebody support their admin costs or some other costs. And so in that case, for a particular project, you might be just covering labor. Okay, so we're going to start off just showing the returns to specialization of some product. All right, so I'm not going to name what the product is. Going to Safari. So I'm going to have some kind of labor units, whether it's by the hour, by the day, by the week, by month. So I'm going to say labor units. I'm going to start off with 0 labor units, go up by, make this a bit more extensive than the previous examples. And so when you hire different labor units, you'll get an amount of output, but if you hire no one, you'll have no output. So the marginal product of labor, called MPL, is going to be the change in total product, or change in Q, divided by the change in, use L for now. I usually use H for hours, use L. And so of course, we don't have any previous one, we can't look at the change. And so when I talk about specialization or returns to specialization, when you have one person working, that person has to do the all the different things that are required in the production process. But if you have more than one person, then once people are different, once they are not exactly matched in terms of all the skill sets, then what we can do is look at what people do better relative to the other person. Are they are they twice as productive in one thing? Are they half as productive in another thing? And so the importance is that people take different amounts of time to do a particular activity. And as long as the ratio of the time they take to do one versus the other is different, then we're going to have a returns to specialization. So I'm going to now pick a Q. I'm going to put a Q here. And so my change in Q is 0 to 100, that's 100. My labor units is increased to 1, and my labor units here are going to continuously increase by that amount. But now, what's the returns to specialization mean? It means that the marginal product, the additional amount I get when I hire that second person, is going to be bigger than 100. And so I'm going to put 150 here, okay? And so what would that mean as my new Q? It means the first person added 100, the marginal product tells you what the second person added. So I added 150, so my total is now going to be 250. What does continued returns to specialization mean? Continue to divide up the work, and my marginal product can actually make it bigger. But so notice my marginal product here increased by 50. Gonna increase my marginal product again, have it increase even more. So it'd be 250. So once you have increasing marginal productivity, the new workers are adding more than the previous worker added. Have returns to specialization. Add the previous amount to the new amount, that gives me 500. Now, what does diminishing returns mean? Diminishing return, I'm going to hire that fourth unit of labor, and my marginal product is not going to be as high. So instead of 250, let's go back down to 150. What does that mean? It means that the fourth unit of labor added 150. So if I had 500 before, I'm gonna add now, right? What does continued diminishing returns means? It means that whoever the next person is that I hire, the next unit of labor, it's not gonna add as much as before. I'm gonna put that back as 100. So if I had 650 before, and the next worker I hire adds 100, we get to 750. Continued diminished returns, I'm going to do this. I'm going to now decrease it, but instead of decreasing it by 50, I'm going to decrease it by 75. All right, so let's do that. So let's say this person just, all right. And so I've got, here we go again, adding 25 to my previous amount of 750. And let's say we got somebody who doesn't add anything at all. So and then of course, oops, I had the 10 label, let's keep this in. And we can at some point have what we call a negative marginal utility. Somebody who's hired and it gets even, we get even. Say we go down like that. And so of course we would just never hire this person because remember, we are once again paying them, right? So you're increasing your cost without adding any value. Okay, so going back to our activity, see what we're doing now. Okay, going back, created. Okay, let's go back. Oops. Stop sharing and share this Word document here. All right. So we've shown a returns to increased productivity, which is the increased marginal productivity is a return to specialization, and diminishing returns, which means that each additional worker is adding less and less. And I'm gonna have to make an assumption to look at what does this mean for marginal costs. And we also are going to talk about the value of the marginal product. So in calculating the value of the marginal product, what do we mean by that? We mean that we are looking at what can you sell, what people make, whatever product they make, what can you sell? What is the value on the market of that product? We have to assume some kind of price for Q, and we're going to assume a competitive market, which means that the price is going to be constant. It's not going to change as Q changes. So you just state the price of Q and state a wage rate for whatever period. All right, so let's do that, and you be making up your own. All right, assume price of Q is equal. Use a nice easy number here. Well, it doesn't matter. I'm using the Google spreadsheet to calculate on my behalf. You could use Excel or whatever sheets that you have. And so I think numbers on Max. You assume the price. So I'm going to assume a price that's not too not too big. Let me just assume $3, right, for the price. So now the value of the marginal product, I'm going to multiply $3 times what it is people made. Oops. Let's check my formula here. I can't use the $sign. I keep forgetting about that. And so it's going to autofill. Oops. Apparently, so let me copy it. The last person, we're not going to have any kind of, we're never going to hire that person. And so if the first labor unit is hired, let's assume that's like a day rate or something like that, then we can see that they are going to add $300 to, or they're worth, whatever they make is worth, okay? And so we would never be willing to pay more than that. The second person or the second labor unit is $450, so we would be willing to pay them that much. The this third person is looking very productive indeed, is the value of what they produce is 750. And then it goes back down. This is the diminishing marginal product. And so, of course, the value of less is going to be less, assuming the same price. And this last person, we wouldn't be willing to pay them at all. They don't bring anything to the table. They don't add. So assume that my labor unit is per day and that the day rate is $100, right? So whenever what's my labor cost? It's going to be equal to the wage rate, and that's not going to actually number of labor units. And W times L. Okay. And so if I don't have any, let me actually put this up here in my labor costs. Wrap that. So what is my units of labor? It's 0 times the rate, 100. Oops, I think I have to hit accept there. Let's just copy. And I'm never going to hire that last person. Okay. So now got to figure out my, let's change formats and to wrap that. So it, keep my, okay. So now I want to figure out the marginal costs. Okay. And this, by the way, we call variable costs. They're costs that actually change with the level of output or the same. Fixed costs stay the same regardless of our output within our capacity. So I'm going to figure out what's the marginal cost, and that's the change in total cost divided by the change in Q. So no, it's not the change in labor units anymore. It's the change in quantity. The marginal cost is how much extra does it cost me to make the next unit. And if we don't have our quantity increasing, meaning we can't tell if we just increase Q by 1, what it's going to be, then we take over a range. What's the marginal cost? There is some assumption that there is a continuous change in the marginal cost in our particular model here. Oops. All right, so now let's get to our marginal cost. I'm looking at the change, 100 minus 0, it was 0 before, and my change in Q. And it's actually going to be the marginal product here because my labor units are increasing by 1. I'm going to actually go to the Q column and do that full calculation. And it's just 1. I want to remember to increase my decimal points here. Let me actually go through this. So I want it to be the change. It's the B. It's E4. It should be. Let me see here. It should be this. 200 is my current cost. 100 was my cost before. And what's my change in Q? My new Q is 250. My old Q is 100. Okay. And keep that pattern formula. So I can't actually divide by 0 again. The value of the marginal product, or the marginal product being 0, I increased my cost. I didn't add anything. So if you don't add anything, but we have to pay, it's going to increase your cost, and we're not going to do that for nothing. Okay, so actually our last 2 units would not be hard. So I want you to notice something about the marginal cost. And I'm going to highlight this. When the marginal product is increasing, when we're hiring more and more productive people, the marginal cost is falling. When the marginal product is decreasing, meaning that we are adding less productive people, the marginal cost is going to be increasing. And I want to make another note here. if the marginal product is increasing at an increasing rate. So what do I mean by that? I mean, I add 100, then I start out at 100, but I add 50, then I add 100. The rate at which the marginal cost is decreasing should also be decreasing. My marginal product is decreasing here, and I had it decreasing at an increasing rate. So my marginal cost was increasing, but then it increasing in a minute. Come back to that. All right. So just a note, marginal cost is increasing at an increasing rate due to marginal product decreasing at an increasing rate. Right. What I mean, I just made the marginal product change drop, but by increasing amounts. Okay, so let's check that we have done everything. So we've created the value, the marginal cost. We look at the relationship. We've created the value of the marginal product of labor. And the importance of that is that we would not be willing to pay workers more than what they actually brought to the table or added. Okay. I'll actually talk about that in a minute before we graph the MC and the MC, or the marginal cost, and the average cost. I'm going to come back to that. So I want to make two things. Let's calculate the average cost is our total cost. In this case, we only have the variable cost of labor divided by Q, not dividing by 0. Take my labor cost is the only cost in this example, and I'm going to divide not by the labor units, but by Q. I want to once again be careful of this decimal point situation. 2 decimal points. Okay, so there my average cost. So I want to notice a pattern. Average cost is decreasing, then increasing. Okay, and so when we graph it, we expect to see the average cost decreasing, then increasing. I also have, and let me actually make a note of this, marginal cost is decreasing, then increasing also. Okay, so those are patterns that we expect, but we expect them because of the pattern of the marginal product. When we hire additional units of an input, what's the pattern that we see? And so it's an assumption. If you don't have returns to specialization, you will not see that initial decrease in marginal cost. Okay, so let's plot this. And again, so just to note that the average cost, actually put that here. I'm going to just kind of replicate the Q column here. And I want to paste this as special and just use the values. And that's going to be matched to the average cost. So this is what I'm going to plot. And when I plot marginal costs, and I'm not increasing Q by 1, not going to bother with the whole entire formula here. I keep my just keep it to 2 decimal places. I'm going to plot at the midpoint of the quantities that we use to calculate the marginal cost. And it's going to be the midpoint of the two quantities or the average. And so that's the new Q plus the old Q divided by 2. Right. So actually go to Braining Camp and remove the numbers that are there. To be colorful here. The marginal cost. Q over here. And in a different color to average. Okay. And so what are the numbers that we need to have? The quantity to go to 775 here. So I'll make it go up to 800. And then we've got these very, very sort of minor kind of try to get 76.762 point here. So if you have a bigger graph paper. So the costs are below $4. So let me put see what I'm gonna do my average cost first. I'm gonna make a point of that, that we actually should note again. If marginal cost is greater than average cost, then average cost will be rising. The marginal will be, and I'll put this, of course, if marginal cost, which we have here with returns to specialization, marginal costs less than average cost, AC will be falling. Let's see, returns to specialization for the first unit, they start up the same, but then there's a declining pattern in marginal cost, which will be dragging down the average cost. If the marginal cost is equal to average cost, then average cost will not change when a marginal unit is produced. Right. And so this has an implication for the average cost to talk about when we draw the picture. And so my various marginal costs are going to be 1 to 4, and my average costs, actually, you can see here, all less than 1. So I'll try to see if I can make that 1, 2, 3, 4, and I'm not going to be able to make it much more spacious than that. $1, $2, $3. I do have to put the $4 here. So as I could put, technically, I could give myself a little more space here. I want to have that space in the 1, 2, 3, 4. Let's do that. And my quantities, 100. So I'm going to have my quantity in hundreds just to stop myself from having to write hundreds. And let's see. I'll do 1, 2, 3, 4. Am I doing that every 3? To make sure I've got this kind of to scale so it looks a little bit right. Every 1, 2, 3 dots will be 100 units. Hopefully I don't make a mistake here with my, I have two dots in between. I want to just make sure I try to be a little bit to scale here. It's not going to look right. We'll talk about what it should look like. Right, so let's plot my average cost, 100 units, 1. That's my first point. 250.8. 250, let's go here. It's the Q, 0.8, so something looks like about there. Not the most smoothest curve. This is supposed to be continuous declining here. Try to get that looking smooth. And continue to die 0.6. Oh, it's the Q there. The Q is 500 and 0.6. Put that there. 0.61, so very close, but a little bit higher. And what's the Q? 650 and 0.61. 650 is about here. 0.61, just a little bit higher. Maybe it's going to be rising a little bit there. 750 and 0.66. 750.66. So that should be exactly here at the 2/3 mark. And 775 and 0.77. 775. So maybe about here. And 0.7, something like maybe this. And so let me see if I can draw. This is sort of declining. It should be following my pattern here. The average cost. Oops. Continues to decline. It's a little bit up. Continues to be going up. This is my average cost. Maybe I did not need to spread it so much. All right. Okay, so now I'm going to add the marginal cost. So my marginal cost, I'm looking at 50 plus $1. 50 cents. It's not, sorry, not one. Let's see how much. It was my Q is 50. And then my MC. So let's see, where's a Q of 50? It's $1. 50 today. Here. That's my start of my MC curve. And then let's go 175 and 0.67. 175. Somewhere maybe around here. 0.67 is about here. And 375 and 40 cents. 375. Here 40 cents. Somewhere right here. and 575, and it's going back up to 0.67. 575. Let's go down 575 right here, 0.67. Right here. Really close to here. All right, so what pattern do we want to notice here? Marginal cost is declining. And the average cost is declining with it. Again, this is coming about because of specialization. As the marginal cost, eventually when we hit diminishing returns, as the marginal cost starts to rise, the average cost is still going to go down as long as marginal cost is below it. And so it's kind of going to cross somewhere here, but I want to make a point about where it crosses. I don't have an exact number here. It's going to cross somewhere. Okay. Let's put our last marginal cost. $701. So it's actually two more. $701 here. $701. Now we have 762 and $4. So 762. So a little bit before that, 7666 and $4 is quite a dramatic drop. Try to get it a little more smooth looking. All right. And that's my marginal cost. So the important thing here is the pattern. Marginal cost is falling due to specialization. It will at some point start to rise because of diminishing returns to the fixed materials that we have: equipment, space, land. But as long as the marginal cost is below the average cost, it will continue to drag down the average cost. And what does it mean? It means even if you have somebody where there's diminishing marginal product, their productivity, they don't add as much as the previous person, but imagine that they're still above the average in terms of their productivity. They're still going to drag up the average. In this case, it's going to be reflected in the opposite effect on costs. Eventually, though, at some point, you hire somebody. In this case, the cost of what they produce, because their productivity is exactly the same as the average productivity. The marginal cost is going to be the same as the average cost that already exists. And that is, let's put this, it's reflected here in what called the minimum. It's going to be the minimum average cost is where the marginal cost is equal to the average cost. Remember what that reflects that the last person you hired is just as productive as the average persons that you've hired before. Okay. Thereafter, that diminishing marginal product is going to mean marginal product is less than average product, going to keep dragging down the average product. And what that means is going to be dragging up the marginal costs. Once the marginal cost is being dragged up above average cost at this point, then it's going to drag up the average costs. This is going to be important when we look at competitive markets. Right. So let's make sure, I think we have talked about everything I wanted to talk about in this activity. So graph marginal costs and average costs. Okay. And so we're going to stop there.